how can we use this to do some analysis other than the break-even point? So we're going to look at 3 examples: sensitivity analysis, unit contribution, and just the degree of operating leverage is really what we're going to be using. Let's start with contribution analysis and look at the margin per unit. And here we have this detail: sales of $69.50, variable costs, fixed costs, these are numbers we've seen, and on the right we've inserted the per unit. This is the sales price per unit. We've already been given that, $1.50 per ice cream. Variable costs, these represent the sum of the variable costs, the direct labor, direct material, the variable manufacturing overhead, and the variable selling and administrative, and that totaled $1.10. So the question here is, how much do they make per unit? And the second is, what is the margin? Margin, again, is a percentage. For every dollar of sales, how much money do we make in contribution margin? So let's solve that in Excel. The easy one is the contribution margin per unit. And what does that equal? It equals the price, $1.50, and subtract the variable cost, which is 1.10. And so that equals plus that minus that, or 40 cents. So this again is stated in 40 cents per unit. So stepping back, for every ice cream we sell at $1.50, we make 40 cents. So next is the ratio, CM ratio. The definition is we take the unit contribution, unit profit contribution, and we then divide that by the sales. So in this particular case, we could do it either on the unit level or the total. Let's do the unit level, is easier. The unit profit contribution is 0.4 and the total sales is 1.5. So the contribution margin is 26.67%. And so for every dollar of sales we have, we make 26 cents in contribution income. All right. So that's the margin per unit and the ratio being a percentage. All right, so if we're going to do sensitivity, again, we've brought this forward just to keep the reference in front of us. Then we have these scenarios. If sales did this, then what? If we did this, then what? So we're going to go through 4 examples simulating changes that may occur in the business. All right, so let's see how much profit we're currently making. We're making $1,000, but let's just put in this context of 0.4 times the units, which is 6,950 minus 1,780. And what should that number be? It should be 1,000. So let's put a plus sign in front of it, or equals, and that's 1,000. So we just proved that this formula here actually works for us because we applied it backwards into what we're currently doing, and it matches, right? So that is the right formula. All right, so let's try it out. If sales increase by 100, what would happen to the profits? So this is an assumption where sales go up and nothing else moves. We have then units of plus 6,950, that's our base units, and plus 100, and that is the number of units. And then we can multiply that times the price. So let's just label these. So these are units, and price is $1.50. Revenues go up by plus that times that. So we'll have 10,570, and then our variable costs is equal to $1.10, and this is per unit, and the variable cost in dollars is plus that times the units, same number there. And then so we have contribution income, and that's the revenues minus the variable cost, and our fixed cost is the same as always, so that is minus 1,780. So profit equals plus the contribution plus that, right? What we've done is we built it up from scratch, the total sales minus total variable cost minus total fixed costs. But we could have done a shortcut. So the shortcut would be what? Well, if each unit makes us 40 cents, then the incremental units should be multiplied times unit contribution. So the incremental units were 100. So I'll just write that here, units. And then the CM per unit is 0.4. That is plus that times 0.4. So that's $40. So when we look at the profit here, that's 1,040 versus 1,000 here, which means the difference is $40. So this all squares up. The 40 is consistent with 1040 minus 1,000. Either we could build it up or simply use the contribution margin that we just derived, the 40 cents per unit, and multiply it times the extra units sold, or 1,000. So this is scenario 1. So I'll just put a box around it, and this is a sales increase. Okay, now we do sales increase, but not in units this time, but in dollars. So sales increase, and now it's going to be in dollars. So notice that we have here the ratio to sales of 26.7%. So we could use it here. Rev increase, and that is equal to 1050. That was what's given to us. And the gross margin percentage for the contribution margin percent is equal to 0.267. The additional profit is simply the multiplication. So this is increase in profit. And we'll box this. Okay, that's the second scenario. Sale increase in dollars. We multiply times the percentage, and we get the increase in profit. Third is if fixed costs increase to 500, what would be the break-even in units? We're going to modify this profit formula. So I'll just put it right here. Profit equals 0.4x minus, but now it's 1780, and we have additional cost of 500, right? So let's just solve that. Profit equals 0.4x minus, and the sum of that is 2280. And we can solve it by bringing 2280 to the other side. 2280 equals 0.4x, which means x equals 2280 divided by 0.4, and the number is 5,700 units. 5,700 units. That compared with the earlier figure that we had that showed 4,450. So it went from 4,450 to 5,700. So this one here is, I'll box that one, and the scenario is called fixed cost increase and break even, question mark. All right. And finally, we say if price increases, what will be the new break even? So same thing, if price increases by 10%. We can use our same profit formula. Profit equals the 0.4, but now we have price increased by 10%. The price was $1.50, so let's just break this out. 1.50, and that is increased now by 10% times 1.1. That's our new revenues, minus the cost stays the same, 1.1, and I'll do brackets, times x minus the variable costs, or the fixed costs are the same, 1780. And just to clean it up, I want to make sure I have braces and brackets and all in the right places. Now, profit, and let's set that to 0. Break even is 0. So 0 equals 1.65 minus 1.1 is the contribution times X minus 1780. So I'm going to clean up my parentheses here. So now we can bring the 1780 to the other side, equals, that's 0.55. 0.55 x. So x equals 1780 divided by 0.55. The answer is 3,236. We always round up to the next nearest unit. The break-even would become 3,236 if our prices were to increase by 10% and we don't lose any customers. That would be nice if they just paid their increase costs. So we've done the 4 scenarios right there. Next, we look at impact of income taxes. What we're going to look at is how can we modify our break-even formula, which is a pre-tax profit, by introducing a tax rate. What we notice is that pre-tax income is equal to the after-tax profit divided by 1 minus tax rate. Because of that, we can then figure out the amount of unit sales if we have taxes. The actual example, again, we're bringing the same base set of data, and now we're going to modify slightly. So here it is. We want to earn $840 in after-tax profit, and the income tax rate is 40%. What are the sales necessary to achieve that? All right, let's try it out with real numbers. What we're given here is that we have an after-tax target of $8,400 and a tax rate of 40%. So what we need to do is figure out, well, what is our pre-tax profit in order to equal that post-tax profit? So let's just go post-tax, or better known as after-tax, profit equals pre-tax profit times 1 minus the tax rate. All right, so let's put the numbers in. Pre-tax profit, or after-tax profit is 840 equals pre-tax, let's just call this pre-tax profit times 0.6. Pre-tax profit equals, now to here, 840 divided by 0.6. So that's 1,400, and this is in dollars. So we say if we want to earn 1,400, that has to equal the price, $1.50, minus the variable cost, $1.10, times X, minus the fixed cost, $17.80. We can bring 1780 to the other side, so that's plus 1400 plus 1780, and that has to equal 0.4x. We can solve for x, and the x would equal plus 3180 divided by 0.4. So 7,950 units would be the break-even, not break-even, units sold to earn $840 after tax. But if you don't believe me, let's try it out. So let's go revenues, VC, FC, and profit, right? That's pre-tax profit. So let's try revenue. So we have plus those many units times $1.50, and variable cost is plus that times $1.10. Fixed cost is 1,780. So pre-tax is revenue minus the 2 costs is 1,400. Tax rate is 0.4. So that's a minus that times that. So it's 560. So after tax profit is 1,400 plus the minus number, it's 840. Right? So this is the target number we were seeking, 840. And the steps again is we derive this number, which is what is the pre-tax. And then after we derive that, we then test it out and verify that it's the right amount. So 7950 are the number of units sold to earn the target of 840 after tax. All right. So that's income taxes.